Hello, so today I'm looking at M3 International A-Level May 2017. This is question 6. This is a question which has a lot of marks, 5 and 8. So let's get started. It says the path followed by a motorcycle round a circular racetrack is modelled as a horizontal circle of radius 50 meters. The track is banked at an angle of theta to the horizontal, where sine theta is 3/5. So I'm going to start trying to draw this, and let's draw the banked track, and there's my motorcycle, and the circle that it's going in is a radius 50, so this is 50 here, meters. Okay, and let's take this to be the centre of the circle here. Theta degrees to the horizontal, so that would be this angle here is theta, which would be the same as this angle here, theta. And if sine theta is 3/5, that means cos theta is 4/5, using the 3-4-5 triangle. So the motorcycle travels around the track at constant speed. The motorcycle is modelled as a particle, and air resistance can be ignored. In an initial model, it is assumed that there is no sideways friction between the motorcycle tyres and the track. Find the speed of the motorcycle. Okay, so I know that the weight of the motorcycle will act down. I don't know what it is, but I'll just call that mg. I know that there will be a reaction force perpendicular to the slope, and if I draw dot, 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 then that angle in there is theta as well. Then I know that the acceleration will be towards the centre of the circle, so I can do a double arrow here. The radius is 50, and for the acceleration towards the centre of the circle, I can either use v squared over r or r omega squared. Now in this case, because we're talking about the speed of the motorcycle, it would be a better idea to use v than to use r omega squared. This one with a v in it, so v squared over r. So I'll write v squared over the radius, and the radius they told me was 50. So now I'm ready to write some equations, and I can draw dot, 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 dot. That's theta, that's not theta, that's theta. So if I resolve vertically, because vertically forces up are equal to forces down because it's not accelerating, so I have r cos theta equals mg. Cos theta I know is 4/5, so I can pop that in here. So 4/5 of r equals mg, and therefore the reaction force is 5 mg over 4. So now resolving in this direction towards the centre of the circle, then I know that r sine theta will be equal to the mass times by the acceleration, which is this thing. So popping in the value of r, I know it's that. So I have 5 mg over 4. Sine theta was 3/5 equals m times v squared over 50. And so now to get what v is, I can see I've got m's on both sides, so I can divide both sides by m. I need to multiply everything by 50. These 5's here will cancel. And so I'm going to get 3 times 50, 150, multiplied by g, divided by 4, is v squared. Oh, silly Billy, so I could have actually divided both of those by 2. Anyway, that would give me 75 over 2. And so v will be the square root of 75g over 2. Okay, I'll just see how they wanted. They wanted the speed in meters per second. So I could leave it like that, or I could multiply 75 times 9.8 divided by 2 and then square root it. And so that is roughly 19 meters per second. Okay, then in the next part of the question, it says, in a refined model, it is assumed that there is sideways friction. the coefficient of friction between the motorcycle tyres and the track is 1/4. So there I was given the value of mu. So mu is 1/4. And it is still assumed that air resistance can be ignored and that the motorcycle is modelled as a particle. The motorcycle's path is unchanged. Using this model, find the maximum speed at which the motorcycle can travel without slipping sideways. Okay, so here, let's just have a look at what needs to change here. So, what will the motorcycle tend to do? The motorcycle will tend to, if it's going as fast as possible, it will tend to kind of slide up the slope. So therefore friction will act down the slope to try and counteract that motion. So the only thing that needs to change about my diagram is that I will now have friction here. So I could draw a new diagram. So I've got the vertical up, I've got R at an angle of theta to that, I've got mg straight down, I've got along the slope, so perpendicular to where R is, I have friction acting, which will be mu R. Mu is 1/4, so I've got 1/4 of R acting in this direction. Here we had ... This is theta, so that is not theta, and that is theta. Okay, we also have the acceleration, which has remained unchanged. Well, the value of v will change, but I'll just call this v squared over 50 this time. Okay, so now this R is not the same as the R in the first part of the question. Why not? Because looking in this direction, things have changed. Before I just had R and mg, but now I've also got this R over 4, which is going to affect this value of R. So this R is different to the previous value of R that I had. So I definitely can't use the value of R that I had previously. So now I can resolve again. So this time I'll get upwards R dash cos theta equals R dash over 4 plus, sine theta plus mg. So popping in the values of cos theta and sine theta that have remained unchanged, I now have R dash times by 4/5 equals R dash over 4 times sine theta, which is 3/5, plus mg. So rearranging this, if I take away this from this, then I get 4/5 minus 1/4 of 3/5. So I end up with 13 R dash over 20 equals mg. So then to get R dash, I've now got 20 mg over 13. Now, resolving in this direction, then I get R dash sine theta plus R dash over 4 cos theta equals the mass times by the acceleration. Here I end up with R dash times sine theta, which is 3/5, plus 1/4 of R dash times cos theta, which was 4/5, is the mass times b squared over 50. And so here I get 3/5 of R dash plus 1/5 of R dash is 4/5 of R dash. makes mv squared over 50. And now I can substitute what r dash was. So r dash was this thing. I can cancel the m's again, and this time multiply both sides by 50 and then square root. So this time I get 20 over 13 times 4 over 5 times 9.8 times 50, and so I get this square rooted gives me this thing, and so I get v is 24.55 blah blah blah, so that will round to 25 meters per second, or 24.6 meters per second. Okay, so that part of the question is worth 8 marks. So you've got 5 marks and 8 marks, so 30 marks altogether for that question. So I hope you found this solution helpful. Do click like if you liked it, and good luck with your studies.